Hi folks, Mr. Long here. I'm doing a screencast right now on equations of planes, and I just need to go over to the correct window, which is right there on Notability. We are still recording, I believe. Good. Yep, we are. And what first thing I want to do is, folks, is I want to just look at this equation right here. Do you see the equation right there? X plus 2y plus 4z equals 16. And I want to know what that looks like. We would kind of think it would look like a line in 3 dimensions. And so, let's figure that out. Now, I haven't told you exactly what we're going to talk about. You probably already have an idea, but I want to take a look at what does this equation look like. So here's what I'm going to do. To figure this out, I can do something I've learned a long time ago. I can get intercepts. So the first thing I'm going to do is I'm going to take that equation, x plus 2y plus 4z equals 16, and I'm going to let y and z be 0. So that's going to be 0. It'll be gone. That's going to be 0. And if I do that, I get 16. So that's my x-intercept, 16. And then down here, I'm going to now let x equals z equals 0. So that means the x is gone, and those z's are gone. It's 4 times 0 is 0. And I have 2y equals 16. Or, oops, that's not x. That should be y. Y is now going to equal, if 2y is 16, 1y is 8. So I've got now a y-intercept of 8. And let's see here. Lastly, if I let x that should be let x and y be 0. So I'm going to let x and y be 0. So that's gone. And then 2 times 0 is 0. 4 z's would be worth 16, or z would equal 4. Well, let's take a look at what this looks like then. So I have an x-intercept of 16. Let's mark that on. So there's my x-axis, and 4, 8, 12, 16. I'll make a dot at 16. So there's the x-intercept of, whoops, why is that not sketching right there? There's the x-axis of 16, the x-intercept of 16. Now I need to get this y-intercept of 8. So the y value of 8, 4 and 8. So there's my y-intercept right there. And finally, I've got a z-intercept of 4. And let's see, z is this way. And a z value of 4 is, there's my z's being measured there. So that gives me right here. So now what I have to do is connect the dots. So I've got a z value. I do not know what's going on here. There. And I've got to connect the dots. So I'll connect to there, and I will connect out to here, and I will connect back to there. Well, if you look at that, folks, it's certainly not a line, right? Because we notice that with our lines, we only got one intercept. If it was on an angle, if it was a diagonal, well, actually you could have 2, but you certainly can't have 3. So what I've got there is a triangular sort of shape. And what that really is, folks, is a plane. We're only seeing the inside of it, but it's an infinite plane. And maybe if I color it in, I'll just sort of shade the middle in a little bit. You can kind of see what it is. It's a 3-dimensional surface. It's flat. It is angled, but it's a 3-dimensional surface that's flat. And it looks like that. Okay, and it has those 3 points right there. So it's got an intercept there, an intercept there, and an intercept there. So that's the equation of a plane. And that's actually the way you graph it. Okay, so and a plane is, just imagine a rigid sheet of paper. That's all a plane is. It can be angled, it can be flat horizontally, it can be up and down, it can be vertical, but it's an infinite sheet, an infinitely flat sheet. And that's what a plane is. And what we see here is we just see the parts that are inside the intercepts. Okay, so that right there would represent the three intercepts of a plane. And just to make sure we've got it, the y-intercept was, I'll mark that, it was 8. The z-intercept was 4, which is right here. And the x-intercept was 16, which is out here. Okay, so, and by the way, that's the way you graph a plane when it's given in this form. This form, by the way, of a plane is called the scalar form. Okay, the scalar form. I'm not writing on my iPad. I'm trying to write on the trackpad on my Mac, and it's almost impossible. Anyway, that's the scalar form of a plane. What I'm going to do in the next screencast is show you how we develop that formula from a vector equation of a plane. So that's it, folks. So if you want to graph a plane, if you get this type of an equation right here, x plus 2y plus 4z equals 16, you simply get the intercepts in Sketch, okay? And there's a real significance there between the 1 in front of that, the 2, and the 4.